Hi everyone, it's Nick DeFilippo, and in this video I'd like to show you how to use digital input on the Arduino to read if a button is pressed or not. So the first thing we want to go over is how a button actually works. So I have these two leads set up with my multimeter, and it's in continuity mode. So what that means is if both of my leads touch each other and they make an electrical connection, my multimeter will beep. So on the back of this button right here, we have four different leads. We have this one, and these two are always going to be connected together whether my button's pressed or not. The other side has these two leads, and these leads don't have an electrical connection unless I press my button. And when I press my button, these two sides come together. So what happens is, if we look at this circuit I got over here, if I can zoom in on it, I have 5 volts coming from the Arduino to one side of the button and ground going through a resistor to the other side of the button. So I have this resistor because when the button's pressed down, the ground's going to be connected to the 5 volts, and without that resistor it's just going to be a short circuit. So if we look at what's going on this oscilloscope, we see that this is 0 volts and the button's not pressed. So when I press the button, it's going to go up, and that's going to be 5 volts. So it went to 5 volts for as long as my button was pressed. And this is what we're going to read in on the Arduino. So I've taken the circuit we just looked at and modified it a little bit. I've put in an LED on this just so you can see what's going on a little bit clearer than using the onboard LED again. And I've drawn the schematic I'm using up in this program called fritzing. So what's happening is I'm taking this 5 volts and ground right here, and I'm bringing them to the power rail on my breadboard, and I'm connecting pin 13 to one side of my LED. The other side goes to a resistor to ground, and that resistor is just to protect the LED. With the button, I have one side connected to ground through a resistor and one side connected to 5 volts. The side with the resistor, I'm reading into pin 2, and that's what you see in my setup right here. It's just a little bit easier and clearer to see. So let's program the Arduino. The first thing we want to do is we want to have some variable declarations, and we're using 2 pins. So we're going to have an integer of an LED pin, and this is going to be on pin 13. Again, pin 13 is connected to an onboard LED, so you don't need this external LED if you're following along and you don't have an external LED. And my integer of my button pin is going to be equal to pin 2. So in my setup, I want to declare pin 13 is a digital output and pin 2 is a digital input. So we're going to use the function pin mode, and my LED pin is going to be an output, and pin mode of my button pin is going to be an input. And that's all we have to do to differentiate between a digital output and a digital input. So in our loop, let's first write down what we're actually trying to accomplish. When the button is pressed down, so I should say, if the button is pressed down, the LED will turn on. If the button is released, the LED will turn off. So what does this actually mean in terms of digital inputs and digital outputs? So every time through, we want to read the state of the button and turn the LED on or off accordingly. And we're going to read the state of a button with this command called digital read. And digital read takes in one parameter, and this parameter is the pin we want to read, which is my button pin. So if this digital read is equal to 1, which means the button has been pressed down, then we want to we want to turn the LED on. So digital write, LED pin, and this is going to be high. And if it's not, so else, the button is released, we want to have a digital write LED pin, and this is going to be low. Actually, I don't need, because in this if statement, there's only one line that belongs to this if statement. I don't need that, that brace. Remember, a digital input means either high or low. High is equal to 5 volts, which is equal to 1. And low is equal to 0 volts, which is equal to 0. So if we upload this to my board, let's call this button press, and it uploads. When I press the button down, my LED comes on, and when I release it, my LED goes off. So it will stay on as long as I hold the button down, and as soon as I release it, it will go off. So it's cool that we can press a button, the light comes on, but it would be rather annoying if whenever we wanted something to work, we'd have to hold the button down. So sometimes a better solution is that we press a button and the light comes on, and we can release the button and the light stays on. Then when we press the button again, the light will then turn off. So let's write the code to do that. And in order to do this, we're first going to need to declare our pin variables again. So we're going to have this integer, which is our LED pin, and this is going to be equal to 13, and we're going to have an integer, which is our button pin, which is going to be equal to 2. I haven't changed the setup at all. And because we're interested in pressing it down, having the light come on, and then pressing it off, pressing the button again, having the light go off, we're going to have to remember the state of the button and the state of the LED. So we're going to have, I'm going to call them booleans because they can either be on or off. So a boolean of a button state, and we're just going to leave it as that. And we're going to have a boolean of our LED state, and this is going to start off as off, so low. Now, in our setup, we are going to want to declare our pin 13 as an output, pin 2 as an input. So pin mode of our LED pin is going to be an output, and pin mode of our button pin is going to be an input. And the first thing we're going to do, we're going to read in the state of the button in case anything changes. It should be low, but our button state is going to be equal to digital read of our button pin. Now, what's going to happen with this loop? We want to press the button and have the LED go on and stay on until the button is pressed again. So that's what the goal we're trying to accomplish. And one thing we have to take into consideration is this actual button that we're using. The button that we're using is a mechanical button, and because it's a mechanical button, that means there's a physical contact that has to be made. And since there's a physical contact, sometimes when you press the button down, it will bounce. And what a bounce looks like is this. So imagine this line is 0 volts and this line is 5 volts. So when we press a button, we want it to go from 0 volts to 5 volts. However, when we press a button, that mechanical the bouncing occurs. So we press the button right here, it jumps up to 5 volts, goes back down to 0 volts, jumps up, and so forth until it finally reaches to 5 volts. So this is called bouncing, and when we deal with these type of buttons, we have to debounce the button. This period typically lasts between 15 to 25 milliseconds, and it doesn't always happen. I was trying to get one of the buttons I have to actually do this and show you on the oscilloscope, but none of my buttons seem to be bouncing right now. So this may occur, this may not occur, but it's good to incorporate this into our design in case it does occur. So let's say you have a counter program and you want to count how many times you press a button, but if your button is bouncing, then if you press it once, it might count 3 different presses. So that's why it's important to consider this. Now there are multiple ways to debounce a button. I'm going to show you a software solution to debounce the button in this video, but there's also hardware solutions that will deal with debouncing buttons. So with a software solution, what I'm going to do is I'm going to take 2 readings and compare them to each other. So I'm going to have an int of my first reading. Actually, I'm just going to call it Boolean. First reading is declared in Boolean second reading. So what I'm going to do is every time through, I'm going to take my first reading. So my first reading is going to be a digital read of my button pin. And then I'm going to delay for 25 milliseconds. And this is typically how long a bouncing will occur. And I'm going to take a second reading. Now, what I'm going to do is I'm going to compare these 2 readings. If they are the same, that means the debounce has either not happened or has occurred. So if first reading is equal to second reading, I'm going to go into this if statement right here. Now what I want to check that this first reading is not equal to, so that's what this symbol means, is not equal to the previous state of the button. So there has been some change of state in the button. So this is not equal to my button state. And then I want to go into this logic. So if these 2 readings are the same and the reading is not equal to what the previous button state was, I want to check if my first reading is high. And high means that the button is pressed down. So, and it's allowing, you know, when the button's pressed down, that's when the 5 volts comes through. So that's what I want to check. I want to only do something if my button's pressed down, not if my button is released. So if my button's pressed down, so this is if button is pressed down, I want to check what my LED is, the state of my LED. So if my LED state is true, this just means it's true. So if my LED state is on, then I want to change my LED state is equal to low. Else, I want to change my LED state to high. Now, you might notice that with these if statements right here, I have this brace surrounding the if statement. And I need those braces in this situation because these braces say that everything occurring between the braces is belonging to the if statement. However, if I only have one line like I do in this if LED state, I don't need those braces because the next line will always belong to the if statement. However, if I had multiple lines, I would need a brace. Okay, so I've checked if my LED is on. If it's on, I turn it low. If it's low, I turn it on. And then I'm going to regardless of the if statement, turn the LED on or off. So LED pin is going to then go to LED state. So pin 13 is going to turn high or low. And then when I'm done with this, I want to change the button state. So my button state is going to be whatever my first reading is. So now we can verify my code. Button toggle. Done compiling, and everything looks good, and I can upload. So now, when I press the button and I release it, the LED stays on right here. Now when I press it again, the LED goes off.